I hope everyone is doing well today. Thank you for joining me. Over the next hour, I'm going to be going through some blockchain fundamentals, and I'm definitely going to take some time to touch on the fundamentals of blockchain, kind of looking through the history, where we are now, and looking towards the future as well. But I'm hoping to spend a majority of time actually writing some smart contracts today and doing a demo so we can see and build a blockchain and see that in action and kind of see some of those fundamentals as we build them into our smart contract. So I should probably stop using the word smart contract without explaining what that means, but basically we're going to be programming different contracts that have functions and then that are going to basically define rules and requirements for the blockchain that we're building. So that's kind of the idea of a smart contract and what I'm hoping to go through today, but I'm definitely going to touch on some things about blockchain fundamentals, cryptocurrency, and more. So I'll show the agenda in just one moment, but I'll just take a moment to introduce myself. My name is Meaghan Lewis, and I'm a technical program manager here at Microsoft. I am on the Reactor content team, so I'm constantly focusing on bringing new content to our Microsoft Reactors around emerging technologies. So I've been a blockchain enthusiast for some time now, so I'm really excited to talk about this topic today. I've also recently just released blockchain content in workshop to the Reactors. So I'm just kind of excited to showcase and demo some of those things that I've been working on today and also in the next session in just a couple days. So now let me transition over to the agenda. And so again, this is what I'm going to be covering, kind of starting with these blockchain fundamentals, then moving into Bitcoin, Ethereum, some of those more popular cryptocurrencies. And then we're going to be spending a majority of the time actually using Ethereum to write out smart contracts. And then I'm going to introduce the blockchain development kit for Ethereum and show what all that has to offer. So this is going to be the basics that we're going to go through today. I hope that's okay with everyone. Feel free to let me know in the comments. Of course, I'll be checking the comments over here to my right, and just hope that y'all are engaged, ask questions. Feel free to let me know if all this makes sense or not. And I also have my coworker Sarah on, who is gonna just help me be moderating the chat. So yeah, I think that is about it. I'm also gonna hop over to my browser. And in the browser, what I want to show first is just the demo that I'm going to be walking through and give you a chance to set up any prereqs for that if you want to follow along now or later. I'm just going to call it out now. So if you go to aka.ms/reactors_online, there you can find all of our online content that we've been presenting at these streams, as well as the blockchain fundamentals work that I'm going to be covering today. So I've started out by just listing some resources in here, as well as the prereqs to go ahead and complete the demos. So I'm going to be using VS Code, the Node package manager with Node.js, and the examples are going to be written in Truffle, which is going to be the development framework for Ethereum, as well as Ganache CLI, the Ethereum client for testing and developing. So I'll definitely go into all these tools in more detail in just a few minutes, but wanted to point this out to get started with and what you're going to need if you want to follow along again. So that's kind of the primer of what's going to happen. So I'll just start with a little bit of a discussion, I guess, or conversation, just a little bit about blockchain. So everyone's here probably because you've heard about blockchain. You have different levels of expertise with blockchain. You might have heard kind of the classic definition of blockchain being this distributed and decentralized ledger that stores records. And when you break that down even more, the blockchain is really just a chain of blocks where each block is going to store transactions, different information about who is actually participating in transactions, as well as a distinguishing feature for that particular block in the form of a hash to uniquely identify it. So all of these blocks are formed together in this chain. And they have transactions in them, which must be verified by others on the blockchain. So that is kind of the basic definition that you got going on there. I'm going to now kind of highlight the actual fundamentals of blockchain and, you know, why it has become one of the most kind of emerging and talked about technologies over the past decade and why I think it will continue to be. So first up is transparency. So blocks are stored basically from the beginning of time of the blockchain's life up until, the very current moment. So there's always a transparent record of any actions and transactions that have happened on the blockchain. It is also secure. So it's really hard to go back and change blocks' contents once they've actually been added. And if you were to actually go ahead and tamper with that block, you could tell because the hash will be different. And then that's an indication that someone has tried to modify that block's contents. So records in the blocks are editable or not editable. They are also not deletable. And then there's identity. So with identity, you have a wallet for a particular blockchain, which will give you a set of 2 keys. So you have a private key and a public key. So your public key is going to be where transactions are deposited to and withdrawn from. And this is also going to be the key that appears on a blockchain ledger as the user's digital signature. So the public key is just a shorthand of the private key, and it's kind of used to identify who you are on the blockchain. But it is very important that you always keep your private key secure, because that's basically how someone can take over your identity. If they were to gain access to your wallet somehow, they can definitely just take your private key and kind of take over ownership of your wallet and be able to make transactions as you. In addition, the blockchain is just more accessible. So when you think about, in particular, cryptocurrency and kind of moving away from a centralized banking system, with blockchain, with cryptocurrency, basically anyone with a phone or a computer can join a blockchain network. So there are just a couple different resources that I wanted to call out now, and I can definitely share all this in the chat. But the first is Blockchain.com, and this is one of the sites where you can go ahead and just come and sign up and basically start participating and buying and selling crypto. So you can get a free account, you can get a free wallet, and it's pretty easy to go ahead and sign up. You can also kind of explore what you can do with this Blockchain.com, which I think is really interesting. You can kind of see different prices, charts, Bitcoin Explorer, so we can take a look at that momentarily. And I was mentioning the blockchain is transparent. So I can see records of all of the blocks here from the beginning of time for Bitcoin, for example, with the latest one here, that was just mined 19 minutes ago. So there's a lot of information just in blockchain.com/explorer where you can come and kind of get a look at different cryptocurrencies and actually visualize their blockchains. Coinbase is also a really popular service where you can sign up to start buying and selling and managing cryptocurrency. Right on the home page, you can kind of just see the different prices for different cryptocurrencies. And it's pretty easy just to get started with buying and selling. So again, all this to point out that blockchain is very much accessible for anyone to get started just by signing up and opening an account. And then of course you have to have some money to buy some crypto, but just to show that anyone can basically sign up from the comfort of their own home. So in addition to transparency, security, having kind of a unique and anonymous identity, there are also rules for a blockchain network. So when you sign up, you have to agree to the rules, and then your computer can receive a copy of the blockchain. And then that blockchain copy on your computer will be continuously updated to reflect all the changes. So like when we go to blockchain.com/explorer and we can see all the transactions here, similarly, you would have access to that as well and kind of see all the latest changes as well. Then there's also consensus that is basically built into the blockchain. And this allows or basically regulates participants to agree on new blocks that must be added. Verification. With verification, this is built into all blockchain networks as well, and there are things called consensus models where basically you need to solve puzzles called either a proof of work, where you can add new blocks to the chain, or a proof of stake, in which stakeholders can verify transactions. So there is a very secure verification system built in which basically everyone can participate to help verify new blocks being added to a blockchain. And the last kind of foundational bit that I want to highlight, at least for now, and again, we'll see more of this as I get into the examples, and I'll highlight all this as I'm building out a smart contract, but mining is another important part of a blockchain. And mining is basically the process of adding new blocks to the blockchain. And the metaphor here is that miners go in and kind of extract some value from the earth. So it's kind of the same idea here with the blockchain, and that miners have to go in and solve some complicated math problem to actually create a new block and then get some kind of reward as a result of that. I'm just looking over at the questions. Is blockchain basically a secure way to have a public database that can't be tampered with at the expense of maintenance of keeping up the hashes? Yes, I think that's the simple answer to your question is yes. So let's talk a little bit more about the history of blockchain. So blockchain technology has really been around for 30 years now, about 30 years. It was created in 1991 when a couple researchers wanted to create a way to have documented timestamps that could not be tampered with. So they created this technology, but it really wasn't until 2009 when Bitcoin came about and was basically the first major application of the blockchain technology. And then, of course, since then, since 2009, we've had an explosion of different cryptocurrencies. And we've seen in the past couple years just more and more applications really being built on blockchain. And now corporations are finding ways to incorporate blockchain into their business and basically to use it for everyday use cases. So it's kind of exciting now to see the transition from, not just focus on cryptocurrencies, but actually thinking about more practical applications where we can use blockchain. One thing that I think is interesting is that there's a book by someone named Melanie Swan. I can go ahead and drop this link in here. There we go. So there is a book, an interesting book that I think if you're definitely interested in learning more about blockchain, I would check this out. But she describes blockchain 1.0 as being very cryptocurrency focused. Blockchain 2.0 is all going to be about contracts and the development of these smart contracts to have transactions of digital assets. And then blockchain 3.0 is really going to be all about blockchain applications and what we can do with them. So I do kind of like that description. I think it's helpful to keep in mind when you think about kind of the history of blockchain and kind of where it's going next. And also just interesting to, again, look at all the different use cases that are being built with blockchain, with banks, with healthcare, with different records, voting systems, supply chain examples. There's a ton of different examples out there about what you can actually do with blockchain. So I will just not really talk to those right now, but I will go ahead and drop in the link there. And you can always Google blockchain application uses and find out a bunch of interesting examples there and what you can do with blockchain. So I will keep moving and talk a little bit more now about Bitcoin in particular. So with Bitcoin, I'll kind of just talk through some of this, but definitely if you want to learn more, you can go to bitcoin.org and find a ton of different information there. But at the core, Bitcoin is digital cash. It was created in 2009 by Satoshi Nakamoto, who is a mysterious figure. We don't know whether, this is an individual or a group of folks, rather. But they introduced Bitcoin as a white paper. And in this white paper, they kind of described the concept of Bitcoin through kind of a set of rules and working code into this white paper. And really what he did was combine a bunch of ideas from other folks, and basically combined it into this idea of Bitcoin as digital cash. So I'm kind of showing this article now. It's a little bit small, so of course, I'm going to drop the link in the chat. And I think this white paper is really interesting. It's only 9 pages. I think it's definitely worth a read if you want to learn more about kind of the basis of Bitcoin and how it works, and kind of understand all these different concepts and how they work together, because I'm not really going to get so deep into this at the moment. But the benefits of Bitcoin is that it is decentralized. Again, you don't have to worry about kind of working with a central authority or bank to get Bitcoin. It has a built-in scarcity system where there's only going to ever be 21 million Bitcoin minted. And that's kind of, it also has a set of rules for folks to participate in being involved in using the Bitcoin network. So that is kind of a few of the key points about Bitcoin. It also encourages folks to participate through a series of different things, like mining, for example, is really big with Bitcoin, where the miners will actually get a reward. The reward originally started out at 50 Bitcoin, but I think as of last week or 2 weeks ago, it's like down to 6.25 is the reward that you get now, as the amount of minted Bitcoin is kind of closer to like 18.5 million right now. The rewards are getting smaller, but we are still definitely, Bitcoin still encourages people to participate by getting these transaction fees and rewards to actually add new Bitcoin blocks to the blockchain. One other interesting thing, so I had earlier showed the Bitcoin Explorer, or this is the blockchain.com Explorer, but it's for Bitcoin. And you can go basically all the way back to the beginning of time to see the very first blockchain. And I think that Bitcoin, I think that this is really interesting. And it's probably helpful just to take a look at what this block is actually composed of. So here we can see the unique hash for this block. We can see that there are loads of confirmations. I think in the latest block, there's probably only like one confirmation at the top of that block, but of course this is the very first one. So lots of people have verified this block. We can see the timestamp that there is an unknown miner. There is only one transaction in this block. The original difficulty for this block was 1. I'll talk a little bit more about that in a minute. A couple other interesting things to highlight is that this block just had one transaction, which was 285 bytes, but a block can have up to 1 megabyte of transactions. So it can have up to potentially, a couple thousand transactions in it. So that's pretty cool as well. And you can also see the block reward that I was just mentioning, and more information about the transaction below. So I do find it helpful just to come and explore a typical block, just so you can get an idea of kind of what is in a block and know what's happening there. One other thing to note is that blocks are added approximately every 10 minutes. So you'll see that this one was mined 18 minutes ago. Oh, this just updated here, 28 minutes ago, 48 minutes ago, 52. So it kind of varies, but it is expected that new blocks will be added every 10 minutes or so. So in the first block, we saw the difficulty level was 1. And probably if we look at this latest block, the difficulty is much, much higher than 1. I don't even know exactly what that value is. So it is much more difficult to actually to mine and to find, to solve the hash for a new block that's being added to the blockchain at this point. That's because there are a lot more users on the Bitcoin network, as well as just a lot more miners. So as there's more miners, we have to increase, and basically Bitcoin will adjust the rules to make it harder to find this new block so that folks aren't finding the blocks any quicker than 10 minutes, and that we're not running out of Bitcoin any sooner than we expect. So I think that that's also kind of an interesting thing. And when you think about just how much the system has evolved and how it kind of continues to evolve and change based on how many folks are using the network and what's going on. And then as you can see, Bitcoin is still the most profitable and probably the most popular cryptocurrency. So next, I want to talk a little bit about Ethereum. I had this page open, it looked like it loaded. I'm also going to take a moment just to look at the questions over here. So let's see. So does Microsoft accept Bitcoin as payment for their products or services? No, not to my knowledge. And would you also be covering Hyperledger Fabrics? Not today, but that is maybe something that I can cover in a future stream, in the stream a couple days from now, if you are interested. So let's talk a little bit now about Ethereum. Again, I'm just kind of pointing out this site. I'm not going to kind of go through like a full in-depth history there, but basically the key points are that Ethereum was created in 2015 by a guy named Vitalik Buterin, and he wanted to extend the rules of Bitcoin, but was met with some resistance because, Satoshi Nakamoto wrote this nice white paper, defined all the rules of how you use and work with Bitcoin. So the core developers really didn't want to stray from that too much. So basically what he did was decide to create Ethereum as a result. And this is an open source programmable blockchain. in which you can actually, code these smart contracts which serve as some kind of agreement between two parties. So you can focus really on transferring digital assets, not just cryptocurrency. While Ethereum does have its own cryptocurrency called Ether, you can basically use it to create any other type of cryptocurrency that you want. So you can think of applications and websites that basically have things like loyalty programs, for example, and that's kind of an example that we're going to be focusing on in just a few minutes here. I'll get coding, where you can actually use Ethereum to create your own cryptocurrencies and kind of use that as a digital asset as a transaction between parties. So I think that is one interesting thing to note, and kind of the difference here is that Ethereum, again, is this programmable blockchain. Blocks in Ethereum are added every 15 seconds, roughly. And we can go back to the blockchain.com explorer and kind of see that. You'll see that the blocks are being mined here at a much, much quicker rate. So that's something that's interesting to note, just as a difference between Bitcoin and Ethereum. The transactions kind of include a lot of the same data. I won't go into a particular block and kind of look through that, and we'll see examples of it as I'm programming a smart contract. But this is just kind of one of the key differences, as well as how you are able to complete transactions. So I mentioned with Bitcoin, there is that 1 megabyte limit. With Ethereum, there is not really a size constraint that you have to take into consideration, but there is something called gas. And basically you have to fill up enough gas. You can think of it, as an analogy with the car. You have to put enough gas in your car to get you where you're going. So similarly with Ethereum, you have to basically put in enough gas to run all the transactions that you need to run. So that is just something that's also kind of unique about Ethereum. And basically they just have these limits in place so that folks don't get greedy and don't, try to mine as many blocks as they can. There has to be some kind of limitations in place and these rules in place to kind of keep people in line and following the rules and playing nicely. So let's see. Next, I'm going to move on to talk about Solidity. So Solidity is Ethereum's programming language. And I'll show just a little bit about how this language works and now and as we do the demo. But it is an object-oriented high-level language. It's kind of influenced by languages like C, C++, Python, and JavaScript. So I think it hopefully will look familiar if you're at least familiar with some of those programming languages. And the typical structure of a contract, I can kind of walk through this. This is basically the key concepts of what you need to know to actually get started with programming your own smart contract. Let me post that in there. So to start with, you have some kind of state variables in which you are just storing some value in a contract. You can set different visibility on your variables. You can make them private or public, which means that they can be visible and used by other contracts. Of course, there are functions, and the functions are really going to be key to actually defining the rules and requirements of the contract and the agreement that we're actually writing. Then there are function modifiers. So with function modifiers, here you can basically just define whether you want a function to only be made available or visible to a particular role or someone. So here's an example of only a seller being able to call this function. And then there are events. So events are very key to Solidity and very key to just programming these smart contracts, because you basically define an event with different parameters, and then you can emit the event that you're calling in a function. And this is actually what's going to be added as a transaction to your blockchain. So you're going to be able to see these events being called. And then just a couple more things here. There is struct types. So here you can have an example that is just a voter, and basically you can define different characteristics about that voter or that object that you're creating. And then lastly, there are enum types. So here basically you can just list all of the variances for a particular state in this situation. So that is kind of the key and everything that you really need to know to actually get started with actually writing your contracts. So we're going to be using Solidity to write contracts, and then we're also going to be using a couple other tools, which I'll call out now. There we go. So I'm also going to be using the help of the Truffle Suite, and I am a really big fan of Truffle Suite and the different tools that they provide. So I'm excited to go through these today. I don't know if y'all have used them, but there are some really cool tools here that make smart contract development really easy and allow you to program, test, and basically kind of get enough confidence in your smart contracts in your blockchain before making them live. So what we're going to be using today is Truffle. So this is a development environment for testing and also just some kind of asset pipeline management. We're going to be using Ganache CLI, not actual Ganache today, but it's kind of the same idea, and it's kind of a personal blockchain of one, basically just used for Ethereum development, and where you can kind of see all the different blocks and transactions being made available here. So we're going to be using in particular these two tools today. And now I think let me just hop over and actually get started with the demo so we can see some things in action there. So let's hop over to the terminal. All right, just needed a quick water break. So from the terminal, what I want to get started doing is first just to show you how you would actually get started with installing Truffle if you need to. So if you do have npm and node, you can just do an npm install -g Truffle to go ahead and get Truffle. All right, and that will just take one moment. I'm going to look at the questions now. So is the hash just a GUID for a saved transaction, or is the data being stored in some kind of binary language? I'm not sure exactly which hash that you were referring to, but I think if we were looking at the blockchain transactions, for example, where they had that unique hash. So that is just a way to particularly identify that particular block that has a set of transactions. So yeah, it's kind of a GUID, but it is actually cryptographically hashed to kind of generate this unique hash for every single block. Okay, so we install Truffle, and then to install the Ganache the Ganache CLI, you can just do an npm install -g Ganache. I can't say that word now, Ganache CLI. And so that is basically what you would need to at least get started with the tools that we're going to be using today. I'm going to go ahead and create a new directory, and then we're going to switch over to that directory. This directory that I'm going to be creating is going to just be called coin, because we're going to be creating a simple cryptocurrency example, which is just going to be called coin. It's not very original for today. And then let's go ahead and cd to coin. And right now I have nothing here. But I'm going to use a truffle command, and I should just show this before I do anything else. But if I were to just list truffle from the command line, I will just get a whole list of commands here. And I can see the various ways that I can use and basically interact with Truffle. So there's a lot of things that I can do to help with my development. To begin, I'm just going to do a Truffle init. And that will just take a moment, and you see that it is preparing to downloading and setting up the box. So before I had nothing in that directory, and you'll notice that I have some things there now. So now I'm going to switch over to VS Code, and let's go ahead and start by opening up a folder. So I'm going to open up that coin folder that I just created, and it is coming. Things are running a little bit slowly today on my machine. Okay. So let me just take a moment to kind of look through the structure that a truffle init command gives us. So we have our contracts directory. You'll notice there's a simple contract there. I'll get into that in a moment. there is a migration for us, and then there is this test directory, which there's nothing there yet. And then in addition to that, I have this truffle config.js. So in this truffle config file, initially it's going to give you out a lot of different commented code where you can basically define the different configuration settings for your project. So there is a lot of stuff here that is here for now, and I'll talk to this in a minute too, and kind of just uncomment and focus on the parts that we need to get started. But this config file is really helpful and basically is going to allow you to connect to some Ethereum client to go ahead and help you run transactions and test and migrate and do different things like that. So let's go ahead and now jump over to the contracts directory. And yeah, so this is just a simple contract that you get just with the truffle init command. And it also kind of just allows you to see more of the syntax for Solidity. This is a .sol file, so that's the extension for Solidity. And yeah, I won't go too much into that. I think let's just start by actually creating a new contract. And I will talk through this as I do it. So I'm going to call this coin.sol. That's how I named my project. And that should be coming in a moment. There we go. So I'm going to start out by using this pragma declarative. And here I can define the version of Solidity that I want to be compiling against. So I'm just going to do a range here and say that I want it to be between 0.5.0 and 0.7.0. And basically, I just kind of define that range to say that, you know, I want Pragma to use this version of Solidity and compile against this version of Solidity, but any other version could introduce some breaking changes. And then I'm going to start by going ahead and defining my contract with the keyword contract, called coin. And then I'm going to start out by defining a couple state variables. So this state variable is going to be of type address. And the address we will see in just a moment, but it is a way to uniquely identify accounts. So this is going to be the public address of an account, and our Ethereum client, the Ganache CLI, is going to give us a list of accounts to get started with. So I'm going to define this new state variable called address. It's going to be publicly visible, and that variable name is mentor. And then next, I'm going to create a mapping. And I didn't cover this, and it kind of wasn't covered really clearly in the Solidity contract structure. But here I'm just going to create a mapping, kind of like a hash map, between my addresses and these balances that we're going to have for our accounts. Let's call that balances. Cool. So those are the variables that I'm going to have to get started with. And then next, I'm going to define a sent event, which I'm going to call out whenever I have sent some money. So that is going to take a from address, a to address, and it's also going to take in, it's also going to take in an unsigned integer called amount. And then next, what I want to do is define a constructor. So a constructor should be part of any contract, and this is going to just basically be called when I create my contract. So this is also going to be publicly available. And in here, I can say mentor is equal to message.sender. And what that is going to do is just say that the message sender is basically the person who is creating this contract, and they are also the mentor. And the mentor is going to be the ones minting or creating code, or minting or creating currency, rather, I think, not code. But we are using code to define how they can create this currency. So, sometimes I let VS Code complete too much for me. So here I'm going to say address receiver is going to be the first parameter, and then the next is going to be an unsigned integer of amount. And then I'm going to make this public as well. Let me go ahead and close this to the side. And so now I'm going to introduce this require statement. So with this require statement here is basically where I'm going to build in additional rules to define what this function needs to do and what it needs to follow. So this first function is basically I want to just add, or this requirement, I want to add a condition that says that the person that is allowed to mint must be the minter. So here we can just verify again that the message.sender is equal to the minter. And here we can say that the sender must be minter. So this second parameter here is just some kind of string statement that we would print out in the case where this rule isn't followed. So we wouldn't kind of go through to the next step at this point, and we just would send out an error message that say, hey, actually the sender must be the minter. And then we are going to add in another requirement that's just going to basically require that the amount that we're sending is not completely absurd. So add in some kind of verification around that. So here I can just say 1e60. So basically that it's going to be less than some kind of amount with 60 decimals. And then I can add another string message to print out what to do if that requirement is not followed. And here, the last step of this function, what I can do is just define what to do when we mint money. So for the balance of the receiver, I just want to increment that amount. And then that is the mint function. And then following that, I'm going to define one more function here, and that's going to be the send function, in which we're actually going to be able to send money after we have been given some money to work with, our fake coin money. And in the parameters, I'm going to define a receiver, a sender, and then also a amount of coin to send. And this is also going to be a public function. And then I'm only going to add one requirement in here where I'm basically going to check that the amount being sent is actually available, that the sender has that amount. So here I can say that the amount is going to be less than or equal to the balance of the sender. And if we try to send more, I can say not enough money. There we go. Cool. And then all I'm going to do after is just to increment and decrement the values respectively from the sender and the receiver. Sorry. Oops. So first let's start with the sender and go ahead and decrement that amount. And then work on adding this amount to the receiver. Cool. And then the last thing that I want to do in this function is actually emit the sent event. So earlier we had defined this sent event on line 7, in which I need to specify the from address, the to address, and the amount. So now let's go ahead and actually emit sent. And sorry, one more time, it was the from, the to, and the amount. So from is the sender, and then the receiver, and then the amount. And there we go. So those are the two functions that I want to focus on for this simple example that are going to allow me to create some coin and actually send some coin. All right, so next, let me transition quickly back over to my terminal. And from here, what I want to do is just actually start up my Ganache CLI just to give you an idea of what this looks like over here. And that's going to be starting up. I do see a question coming in. How does Solidity deal with concurrency? And should there be locks or mutex around this? And that is a good question that I'm not necessarily sure of the answer to, or I haven't really seen that in the contracts that I've built and explored. But we can look at that in about 10 minutes after I finish the example and see how Solidity can deal with this. So I just started up my Ganache server, and here you can see that I am given these 10 accounts with an amount of test ether to begin with. So you can see the address of each of these accounts with a corresponding private key for each of the accounts, as well as my wallet. And then I have this mnemonic, which is a phrase so I can access my wallet. This is very much not secure at this point, but in a scenario where you're working with a real Ethereum client and working with real Ethereum or Ether, you would want to make sure to keep this mnemonic safe so that no one can then get access to your wallet and get access to your private keys. But for testing, it's really nice just to see how all of this works together. You can also see the gas price here, the gas limit, and then the call gas limit, which I think should be maybe a combination of the gas price and the gas limit. I can also see that this Ethereum client is listening on my local host at port 8545. So what I want to do before going any further is just making sure that my Truffle config is actually pointing against this development environment. So going back to VS Code, I'm gonna go ahead and jump over to the Truffle config. And you'll notice again, there's a lot of things commented out here, or commented. So I'm just gonna go ahead and comment out these few lines in here to specify that I'm gonna be working with a development environment. It is going to be at my local host and running against port 8545. So there can be different ports that we use for different Ethereum clients. So I'm just showing Ganache CLI. If I was just using the Ganache UI, that's a different port. I think that's 9545. Truffle also has a built-in Ethereum client that I can use, which I think is port 7545. So they're all varying slightly. So just it's good to take that into account so that you know which client that you're pointing against and you can set that in your config. So the next thing that I'm going to do, I want to write a test for this, but before I do that, I should just go ahead and create a migration. So here is where you see the sample migration that we're given, this migration to migrate the migrations basically. And here what we basically do is just define the contract that we want to work with, and we use this JavaScript function to actually go ahead and deploy the function for us. So what this is going to do is just make our contract available on the Ethereum network, which is, what we're working with right now is the Ethereum virtual machine. So this development network. And I'm going to go ahead and create a new file that is going to be, it's going to start with 2. So basically the best practice here is that you would continue to increment your migrations, kind of how you would do like a database migration. And this is going to be called deploycontracts.js. Note again that this is written in JavaScript. And I'm just going to go ahead and copy this over, since the syntax for every migration is generally going to be exactly the same. So instead of a variable called coin, our migrations, I'm going to go ahead and call it coin, which is the name of our contract, and then I can just go ahead and replace that everywhere. So now I have this coin migration, which I will run momentarily, but now let's go ahead and switch over to the test. So for the test, I want to define a new JavaScript file called coin.js. I do write test with Solidity in JavaScript. You do also have the option to write test in Solidity. I think JavaScript is just the option to actually kind of test your contracts as you would use them in the real world, and kind of get more of that idea to kind of see how you can test out the function in different ways, or the contract. So now I'm just going to write a very simple test. It's super important that you do write a lot of tests for your contracts, just to, again, kind of make sure everything is working as expected before you do any kind of deploying or think about deploying to production. So here I'm going to define a new variable called coin and say artifacts.require coin. And this basically is starting out the same way as my migration so far, where I'm just defining the contract that I want to work with. And then here I'm going to next define a variable for Truffle assert, which is the assertion library that is provided by Truffle. So it's nice that they have their own built-in assertion library. So require Truffle-assertions, and here I'm going to then specify the coin contract, and that I want to use the accounts that are available to my Ethereum client. And next I'm going to actually define the test function. So I'm going to use the syntax it. So this is just using the JavaScript Mocha library here. So it should mint and send coins. Let's call that. And then this is going to be an asynchronous function, and I'll talk a little bit more about that in just one moment. And so this is asynchronous basically because I'm going to be running a series of commands. So I'm going to define this C variable for coin, and then I'm going to use that corresponding await syntax. So since JavaScript is a single threaded language, I need to make sure that when I'm basically running these tasks that I'm waiting for them to kind of come back and have a result before I'm moving on to do anything else. So here I can say await coin.deployed. So then after the coin is deployed, then I can add another await before moving on to this next line where I'm actually going to call the mint function. And here I'm going to be using accounts 1, which is just going to be that first account, or actually the second account. Account 0 is the minter in the situation, which is going to be allowed to create the coin. And I'm just going to send some sample amount of coins in that case. Oh, and I do have a typo here. No, wait. Okay, yeah, that looks better. So then after this, I'm going to say let result is equal to add another await c.send. So here I'm going to call that send function after we have already minted a certain amount to account 1. So from the send function, just one moment, let me go back to the contract. We have the receiver, we have the sender, and then a certain amount of money. So let's go ahead and say that we want to send this to accounts 2 from accounts 1 after we've already given them a set amount of money. And let's go ahead and send 200 coins. And the last line of this, I'm going to call Truffle assert. And I want to assert that this event that I've defined in that send function was actually called. So here I can say assert.event emitted, pass in that result, and confirm that the event emitted was called send or sent. And that's a basic test that I could write. So this is just kind of testing the happy path to get started with, right? Just kind of the happy scenario that indicates everything is going to be working. So now let me go ahead and open up the terminal in VS Code. So I do have, again, the Ganache CLI running in the background, so I can run different Truffle testing and migration commands against this. But I'm going to go ahead and start with a compile to just make sure that my contracts work as expected and can compile successfully. That is taking just a moment. Cool, and then you'll notice that it will compile both the coin and the migration Solidity files. And then I can run a Truffle migrate to go ahead and make sure that we can run that migration and then deploy that contract to our Ethereum client. Cool. And then that is running, and you'll see here that it is running against the development environment using this network ID. You can see that this actually does generate a transaction, so I get that unique hash for this transaction. It creates the first block on our blockchain. And then I also just see some other binary data about this. So I can see that it used up a slight amount of ether from, should be the first account, that there was no ether sent. And again, we see the total cost there. So that's kind of cool. And I can switch over to my Ethereum client and I can see similar information here. I see that actually a few different blocks were created when the contract was created. This should be the migration being run. So I can see these different blocks and transactions already being added to my blockchain. All right, so now going back to VS Code, let's go ahead and actually test out. Oops. Let's go ahead and test out our contract to make sure that everything works here. So I'm going to do a Truffle test down in the terminal. All right, and that should just take a moment as well. Okay, and this also does some compiling of my contract. So if I have changed anything, I could just run a Truffle test and not have to worry about recompiling those contracts. Oh, right. So I did actually require this npm package before installing it. So let me go ahead and do that now. So I'm going to do an npm install truffle-assertions and run that. And I should actually get a warning here because my project doesn't have a package.json where I can define all these external dependencies for my JavaScript project, but it's fine for now. If I did want to continue working on and building out this example, I should definitely add that since that would be a best practice. But now let's go ahead and run Truffle test again, and this should pass. Just a moment. Okay. All right, more compiling. Things are happening. All right. So it took just a moment, 505 milliseconds to run this test precisely. But here I can see that my test did run successfully. So here I can kind of just get a basic idea that my test is working. Probably my function definitions for both minting and sending currency are working okay. The next step here would be to add some more tests and not just kind of go through the happy path scenarios, but I should actually test out, like for example, these requirements that I built in to make sure that we can't mint more than this amount, that we can't send more money than we have, that other scenarios there that are basically going to help me to more thoroughly test out my contract and have more confidence in it. Going back to the terminal again, I should just be able to see now that there are going to be more blocks since my tests were run and they actually were calling those different functions. So I will see different transactions listed here for each of that. I will say that just by kind of looking through the Ganache CLI, it's maybe not always the clearest what's happening here. You can definitely see that a lot is being added, that there are new blocks with new transactions being added, but it's a little bit more difficult to see exactly what's going on here. So in the next session, I am going to be using the Ganache UI so that we can actually visualize the transactions a little bit more. But it is nice to at least kind of keep track of what's happening here, how much gas that you're using, the new blocks that are being added to your blockchain. Even just when you're actually just testing. So you can kind of see and get more of an experience of how your blockchain is continuing to grow. So that is where I'm going to stop with this example for now. One other thing that I did want to call out before I kind of close down and answer some more questions, if you go over to the extensions tab, which is kind of this building blocks looking one, you can look for the blockchain development kit for Ethereum. So I already have this installed here, but if you were to install it, you can get even more support in addition to using Truffle, you can get even more support basically for creating and managing your smart contracts and even deploying your smart contracts. So I'm going to be showing this off in the next session, but just to give you a little bit of a sneak peek, what you should be able to see is when you right click on a contract is that this menu will come up and you should be able to see more options than you had before, where you can build contracts using the extension. And I can just open up the terminal and you can kind of see the output from that. If I look for, do I see anything blockchain here? I don't, but I should be able to see the output here. Okay, I'll come back to that, but you should be able to see that here because I think you maybe saw a little banner at the bottom right that it said that it was building. Oh, there it's going. It's still building in the bottom right corner. You can then also deploy contracts from here. And then you can use the smart contract interaction page. So that provides a little bit of a UI where you can actually then see these functions and call them using sample values here as well. So you can kind of have a more visual option as well. So there's just a bunch of options that basically just allow you to work with your contracts in different ways. I just clicked on the deploy option, for example. So here is just an interesting way where you can see that I have options using the blockchain development kit where I can either do a local deployment or I can also deploy to Azure Blockchain Service, for example. So we'll get more into that and kind of other tools and the Azure blockchain set on the next session. So I think that's about everything that I want to show here for now, if I am not mistaken. So yeah, I think let me switch back over to my video for now. Yes, so just a couple things I think to call out before we finish for today, and I'm going to share some resources and then just answer questions like I said. So if you do want to follow along more and try this out on your own, you can just go through the example that I went through. I'll share the GitHub link down below. And also just if you want to learn more about Solidity and Ethereum, there's also resources in there to kind of point you to doing that. But yeah, this is about it that I have for today. So I hope that this has been informative so far and kind of just given you a little bit of idea about how you can get started programming your own smart contracts. This was just a very simple example today, creating your own coin examples, but you can kind of explore lots of other examples as well. So if I go back to the browser, I would definitely encourage you to explore the Solidity website more that I was just looking at, but I closed it. So to go ahead and explore this and kind of read the documentation more. The last question was the rest of the files in the Reactor GitHub repo. Is there a curriculum for those? Are you asking for the blockchain curriculum in particular? There is a blockchain directory where you can see more of the curriculum, which has a little bit more of building out a kind of full-fledged smart contract example with many contracts working together. Yes, so let's see, what questions did I not answer that I said I'd get to? Okay, so there was the question about concurrency. Yeah, which I'm still not sure of, so let's actually look up that. And thank you all for joining. Yeah, I need to look up this concurrency example. It's probably not the best way to just search here by typing concurrency. But yeah, I'm gonna actually look into that and I will get back to you. Who asked that question again? Oh, J314159. Thank you. Yeah, let me get back to you about that. And also, feel free, I'm just going to put this up now. Feel free to reach out to me either on my Twitter or my LinkedIn is the best way to reach me. If you do want to talk any more about this stuff, I'd love to talk about it. I'm still learning quite a bit and exploring quite a bit, but I am very much a blockchain enthusiast, so feel free to reach out to me there. And I also just want to encourage you all to take the Reactor survey for this session. It's very quick. It'll take you probably 2 minutes, and there is the event code. I could also post that in the chat here. Thank you, Sarah, for posting that. And the event code is 7345. So yeah, that is it for now. I'm going to hang around for just a couple more minutes. You can't see me, but I am talking and still looking up some information in the back. And I hope to catch y'all at the next session as well in just a couple days.